Hello, YouTubers. I'm doing a test here, very preliminary test, with glass wool mat. You can see a section of it there serving as strictly a separator. And I have graphite felt, light nickel plate on the top and bottom, two sections of it, and the glass wool mat in between them. And the glass mat that I'm testing out, I obtained on Amazon, Grifco products. And it's by mass, an ounce of chopped strand fiberglass mat, 1 yard, very inexpensive. I can't give you the price in US dollars, but it's very, very cheap compared to some other materials we use with Supercap designs. There's a square yard, and that would be 0.91 square meters. 1.27 meters times 0.66 meters. The thickness of it, I measured with a caliper, and I'm getting 0.25 millimeter thickness of this fiberglass mat. And with certain supercaps, we're going to be using this separator with some aqueous-based electrolytes. We're interested in the performance of the modified graph felts as electrodes. For example, with carboxymethylcellulose, we'll bind some very fine activated carbon with some electric black, carbon black, very good conductor, of course. We will bind some on graphite felt, and we will then be testing out the performance on a small scale with this fiberglass mat. And we'll be testing out, in particular, concentrated phosphoric acid at about 1.2 to maximum 1.3 volts. We want to see how the glass mat will hold up after a number of cycles. We'll examine it by scanning electron microscopic imagery. And we want to look at the surface of the graphite felts that are serving as the electrodes. We're also going to be testing out a deep eutectic solvent, which has been prepared from choline chloride and concentrated phosphoric acid, 1-to-1 mole ratio. We want to test that one out because I think we can boost the voltage. We might be able to get to 1.3 volts, possibly 1.4 volts. And what I did was to take the glass wool and I coated it top and bottom with this DES I just showed you, just to do preliminary work. And my concern is that I don't want two sections of graphite to short out. So I may have to put a second layer of the fiberglass as separator between the two graphite electrodes. We'll see. That's why we're doing this. Now, what I did up here, I charged this up. I have it in a series with two commercial supercaps. I've been doing a lot of work with these supercaps just to go to higher in series. Each one is rated at 2.8 volts, so I can go up to 5.6 volts as a ceiling, but I'm going nowhere near that in this experiment. And what I did was I charged this up to 1.4 volts. And then when it maxed out at 1.4 at a cutoff of 0.15 amps, the nominal voltage I got was 1.235, as you can see down there. So there was a small drop off from charged up to 1.40, and then it dropped down to 1.235, and that was in about a minute. So I started at that potential. That became my open voltage, 1.235. And then dropped down, some resistance as always in the beginning. It dropped down to about 1.08 volts. And I was discharging at 100 milliamps with a cutoff voltage of 0.20 volts. And capacity was 8 milliamp hours. And it ran for, maybe 5 minutes. Just doing a preliminary test on this. I've not worked with the fiberglass mat, but I think it has great potential, and I know it's used in certain batteries. And I'm also working with chitosan thin films and agar gels. But now we'll begin to take a good look at this fiberglass mat. Thank you for watching. Bye for now.